This demonstration is an acid-base reaction in the presence of a universal indicator. In the tube, we have hydrochloric acid and the universal indicator. I'm going to add sodium carbonate, and the carbonate is a base. So we're going to get an acid-base reaction between the hydrochloric acid and the carbonates solution. Now, the carbonate solution is actually very dense, and that's going to cause it to drop to the bottom of the tube, resulting in varying degrees of an acid-base reaction throughout the tube. So we're going to let it sink to the bottom. They're going to rotate it upwards. And what we're getting now is a gradation of colors. In the top, you'll start to see that it's red, and you might even see that some orange and yellow and green and blue and purple in there. And so at the top, we have the least amount of an acid-base reaction. In other words, there was very little interaction between the carbonate solution and the hydrochloric acid. This means that we have acidic pH due to largely the presence of the hydrochloric acid. As we move downwards, we start to get more and more color variation. And at the bottom of the tube, we see largely purple. And the purple is due to the excess base because we have a basic pH. Now, as we let this sit here for longer, we actually will get something that looks more like this. So again, we have varying pHs, acidic to more basic, due to varying degrees of an acid-base reaction. At the top, again, is mostly the HCl. In between here, where we have the yellow and the green and the blue, we're getting varying degrees of the acid-base reaction. And at the bottom, we have largely the carbonate solution, resulting in a basic pH. So more acidic to more basic.